Okay, this is a brief lesson on Pythagoras' theorem and finding the different side lengths in a right angle triangle. We've talked a bit about this, but this is kind of bringing a few ideas together. And yeah, I'm just going to go through the examples, and then you'll have some Khan Academy questions to work on. So this is Pythagoras' theorem. It says a squared plus b squared equals c squared. It's the relationship between all of these lengths if you have a 90-degree angle in a triangle right here. So super famous. We talked a bit about it in class, the history and things like that. So just going to work through some examples on how to actually do some calculations. So obviously our goal with this is to do something more interesting than just calculations. But we can use this theorem to calculate the height of something. So maybe a tree or a building or a mountain or something like that. If you know two of the lengths, you can calculate the other one. Maybe a measurement of some right angles that you see around you to verify if it's true or not, to see if it works. And people often use this to make sure that corners are perfectly 90 degrees, that they're not out of shape. And Pythagoras' theorem is a way you can check if something has a right angle or not. And we can talk about that in class later. But for now, I want to practice some of the calculation pieces. So if you look in the background too, there's an example of a wire hanging from a cliff, and this guy's like zip lining down, and maybe we'd need to do this to calculate the length of that wire. If you know how high the cliff is and how far away he's going to go, that's a perfect example of using Pythagoras' theorem in real life. A few pieces of terminology. The hypotenuse is an important word. It's a unique word just to represent this side of a triangle. We don't really use this word anywhere else except in this situation. But I'm going to use it when I talk about this stuff, so it's important to know this word. It's always the longest side, and it's across from the right angle. So if you look at the right angle and you look across from it, the hypotenuse is that side length. And then the other two we call legs. They're not necessarily the same length, but the words we use to describe these two are the legs. They're the two that make up the right angle. They join together to create the 90-degree angle. So for this example, finding the hypotenuse, I'm going to try and draw on this board here. Okay, so we're going to do, we want to find this side length here. So we're going to use Pythagoras' theorem to do that. So we take 56 squared and we add it to 42 squared. Okay, while I'm typing this or writing this out, you guys can do this on your calculator to check your numbers are the same. Okay, so 56 squared plus 42 squared. When we do these two and add them up, actually I'll write them down. Just go to look on my page. Oh yeah, 3,136. It's not easy drawing on this computer, by the way. And 1,764. I mean, imagine I wrote like this on the board. That would be embarrassing. Okay, and when you add those two together, you can do it now while I'm writing again. You get 4,900. Okay. Clearly, this length is not 4,900. If this is 42 millimeters and this is 56, this is 4,900? No way. So we always need to take the square root of our final answer here. And the square root of 4,900 is 70. 70 seems like a bit more reasonable number, and it's in millimeters, which is our unit of measurement. So 70 millimeters is the length of that one. And Pythagoras' theorem shows us how to do it. The questions you did last class were like this. I just wanted to review. So let's click over to the next page. All right. Now, if you're given the hypotenuse, this is the length of the hypotenuse here, and one of the legs, then we have an additional step to do. So instead of adding the two pieces together, remember our formula is a squared plus b squared equals c squared. Wow, this is way harder than I thought. Okay, so a squared plus b squared equals c squared. C squared is always the hypotenuse. Okay, in the way that they've written the formula, they're saying that if you add the two legs together, you get the hypotenuse, if you square them, of course. So if we were to rearrange, if we know the hypotenuse in one of the legs, the formula actually looks like this. C squared, the hypotenuse squared, minus one of the legs. So in this case, it's going to be a squared equals the other leg to the power of 2 also. Okay, and maybe we talked a bit about this before the spring break, but so in this case, we're going to do 17 squared, and we're going to subtract one of the legs. In this case, the leg is 15. It's the one that they gave us in the question, and that's going to be the way that we get to find b. Okay, so 17 squared is 289. Sorry, what am I talking about? I was thinking 13 squared. Okay, 289 and minus 15 squared, which is 225. I know that one off the top of my head. And when we subtract those, we end up with 64. Okay, is equal to, and I should write that on all of these, equal to b squared. Here, b squared as well. Okay, the square root of 64, as you know, is 8. Hopefully you know that. So the side length b is 8. And that makes sense. 17, 15, and 8. Those are nice numbers. Reasonable. 64 is way too long of a measurement for b. So that's the first two types of examples. You're going to see another type of an example on Khan Academy. Let's just clear the screen again. And here's an easy version. Small numbers, 4 and 2, but you're looking to find one of the legs. So we need to do 4 squared, take away 2 squared. So 4 squared is 16, take away 2 squared, which is 4. 16 take away 4 is 12. Okay, but this is not 12. Maybe it gives you a 12 as an example. I can't see it because my screen's cut off. But of your options here, these ones all have a square root. And sometimes it's easier to write the square rooted version. Remember, this isn't going to be 12. It's going to be the square root of 12. Sometimes it's easier to write the square root version like this, square root of 12, than it is to write square root of 12 is 3.464 and so on. 0.464. Okay, and it keeps going and going and going and going and going forever. It's not a good idea to write this number around it. It's much nicer to write square root of 12 because it's easier, it's exact, and if somebody wants to know what is the square root of 12, they can just put that in their calculator and they can get 3.464 and all of the numbers after it without you having to write it. So in the Khan Academy questions, they write their answers like this 99% of the time, I think. Okay, so I've assigned it to you as an activity on Khan Academy. You can go and find it there. Here's everybody's name. And the name of the topic is this. You have to log in, and I will see your score here, hopefully 100%. And if you don't get 100%, you can do it again and again, and I will be here to ask questions and help you. All right, good luck. Thanks.